Hi everyone, welcome to this video where we're going to talk about how to find the zeros of a function using our TI-84 plus CE graphing calculator. Ready? Let's take a look. This lesson goes right along with a free resource that you can access in the description below. It's a link to my Teachers Pay Teachers page with this resource that you can download and give to your students for free, and they can use this video to help them learn. So let's get started. First off, finding the zeros of a function means 2. When you ask your students to find the zero of a function, we want to make sure that we explain to them that we're trying to find the values of x when y equals 0. Now, when y equals 0, we want to talk about that when y equals 0, that's actually where it's on the x-axis, because y equals 0 is actually the x-axis. And so we want to see, where does the function actually cross the x-axis? Where are those x-intercepts? So, grab your graphing calculator and let's take a look. So find the calc option on your calculator. Where did you find it? Many students might not know where the calc option is on their calculator, so you kind of want to look around with them and notice, is it on one of the main buttons? Do I see calc on the main buttons? And eventually, hopefully, one of you may find that it's actually above the trace button on your calculator. So I would have my students write down that the way to access the calc function is to click second, the blue button, second, and then trace, okay, to access that calc function. So on my emulator here, if I go to second and then trace, I access that calc function. Now today we're talking about how to find the zero, where to find the zero. What option on our screen right now shows us to find the zero? You see it, right? It's just simply the second option. So I can either use my down arrow to access that option. I could press the number 2 or type the number 2, and it's going to give me that option, and I'm going to be able to calculate my zero that way. Are you ready to find those zeros? Are we ready to actually graph some functions and see where those zeros are? Obviously the answer is yes. All right, so let's take a look. So we're going to find the zeros of this function, f of x equals negative 4x plus 8. So follow along with me. Ready? You're going to go to y equals, and you're going to type in the function. So I'm going to go ahead over to y equals, and I'm going to type in my function. And my function is negative 4x plus 8. So my function is negative 4x plus 8. Okay, awesome. Next step. Next step says that I'm going to press graph to see the function. Where are the zeros? Where are the zeros? The zeros are the x-intercepts, where it crosses the x-axis. And I think we can probably tell pretty well just by looking at this graph that it looks like it's crossing the x-axis at 2. But do I know that for sure? Well, we're going to make sure that we know for sure if it's 2 or not. So we know that the zeros are where the x-intercepts are, and I see that there's one x-intercept. But now I want to use my calculator to just make sure that I think it looks like it's positive 2, but let's let the calculator tell us for sure. So it says press second trace to access the calc function, select option 2, 0, right? And so we already practiced that already, where we go into here and we go second, trace to access the calc function, and we're going to go down to the second option that says 0, and we're going to press enter. And we notice that there are some questions that have appeared at the bottom of our screen. All right, so it says notice a blinking cursor on the screen, the function at the top of the screen, and the question at the bottom of the screen. So again, we notice that we have the function at the top, y sub 1 equals negative 4x plus 8. We notice our cursor is blinking at the y-intercept here, okay? And we notice we have this question at the bottom that says left bound, and notice the ordered pair that they give us, 0, 8, is actually where the cursor is blinking. So what I need to do now is I need to, for the question left bound, move your cursor so it is located to the left of 0. So we want it to be to the left of 0, the left of where the x-intercept actually is, and press enter. So when I go ahead and do that, I'm going to move my cursor so that I know my cursor is to the left of that intercept. It's also above the x-intercept in this case for this graph, but I definitely know that my cursor is a little bit to the left of the value that I want to find, and I press enter. Now notice that my question did change. So when the question changed, it now is going to ask me right bound, and that means I need to move my cursor to the right of the 0 and also press enter. Now, my little note here on the side is that for left bound, that cursor should kind of be above the x-axis in a way. It could be a little higher than what I have it, but we don't want it below. And then notice that when I go to select right bound, and I move my cursor to the right a little bit more, that I do want my right bound, I want my blinking cursor to definitely be below the x-axis for this particular function. That's going to help me figure out where my 0 is, and I'm going to press enter. Notice that the intercept that I want to find, the 0 I want to find, is in between those dotted lines, and that means that I'm doing this correctly. For the last question, guess. Make sure your 0 is in between those vertical dashed lines, which it is, that are on your screen, and press enter. So now at the bottom it says guess. Do I want to know it? I press enter, and boom, it tells me my 0 is at 2, 0, which is my ordered pair of 2, 0, and we knew it was 2, but the calculator told us for sure. They're not always going to be exact values. Sometimes they could be decimal values, and so we want to use this calc function to get the exact value of the 0. And of course, we know we were right. The value of the 0, x equals 2, is at the bottom of the screen. Now, listen, we're in a math class here, and we know that we can use the calculator to find the 0, but we also know mathematically we can find the 0 just using pencil and paper. So we can find the zeros of a function manually by solving an equation. Find the zeros by solving and graphing. So we're going to take a look at these two functions, and listen, to find the 0 of the function means to figure out what are the values of x when y equals 0. And we know that f of x is the function way of saying y equals. And if I substitute a 0 in for f of x where y actually is, and I solve this equation, I'm going to be able to find the 0 of this function. So if I take f of x equals negative 3x plus 6, and I replace f of x with 0, which is a way to say that y is equal to 0, and I solve this equation by subtracting 6 on both sides, I end up getting negative 6 is equal to negative 3x. I divide both sides by a negative 3. Notice what I am left with. I am left with x equals 2. Okay, let's keep that in mind. So the value of 2 equals 0. So 2 makes the y value become 0. Over here on the right, same idea. If I replace f of x with a 0, and I start solving for x, and I subtract 20 on both sides of this equation, and then I divide both sides by a negative 8, I end up getting x equals 2.5. Okay, so the value of when x is 2.5 lets the y value become 0, so I know that that is my 0 of my function. But now we're going to be able to actually graph these functions and say, hey, the first one gave me a 0 of 2, the second problem gave me a 0 of 2.5. If I use my calculator, am I going to see it that way? So that's what we're going to do right now. We're going to actually graph those two functions, and then I have one more function at the end here, and we're going to be able to throw a little sketch into our paper of what our calculator actually looked like. All right, so I'm going to head back into my calculator. I'm going to go back into y equals. I can press clear to give me a fresh equation to work with, and I'm going to type in negative 3x plus 6. I'm going to press graph so that I can see my graph of my function, and now I want to calculate this 0. So I do second, trace. I go down to the second option of 0, press enter. I want to make sure that my cursor is left bound of my x-intercept, which about here looks great. I'm going to press enter. I then need to have my cursor right bound of the 0, so I'm going to click the right arrow a bit until I know that my cursor is definitely to the right of that x-intercept, and press enter. The final step, press enter again for my guess, and look, it does tell me that my 0 is at 2, 0. So what you're going to do is you're going to go back to your page, you're going to make a little sketch of this graph, and we can confirm mathematically and graphically that we got 2 as our 0. Next one, f of x equals 20 minus 8x. We already calculated this by hand, but now if I go back to y equals, I clear out the equation that I had. I type in 20 minus 8x, and then I press graph. I am going to notice at the top of my graph, I don't see the y-intercept, but that's okay. I really care about the x-intercept. That's my 0. And I notice that, oh, it does look like it's somewhere in between 2 and 3. I don't know if it's exactly halfway in between. I don't know if it's 2.4, 2.6, 2.5. So we let the calculator tell us for sure. So we do second trace, which is the calc function. We go down to the second option to calculate our 0. Press enter. We right arrow over, and this may take a while because it was all the way at the top where the y-intercept would have been. I get my cursor close to being left bound of my intercept, press enter. I then need my cursor to be right bound, press enter. Guess, yep. And look what we get. We end up getting x equals 2.5, which is exactly what we had when we solved it manually. So solving an equation manually is great. Solving it by the calculator is also a great skill. Now, the last one, we did not solve this one manually, so we're going to let the calculator show us exactly what it looks like. So I'm going to go back to y equals. I'm going to type in x squared minus 4. Okay, x squared minus 4, and press graph. What's different about this one? How many times does this graph cross the x-axis? It actually crosses it twice. So I can see that my intercepts are at -2 and +2. So that's what I think my zeros are going to be, but we can use the calculator to check. So second trace, second option, go down to 0. Now I have 2 zeros that I can calculate. So if I say I want to be left bound, maybe I'll start with the one on the left, press enter, head over to the right, press enter, press guess, and yes, we are correct. Our first 0 is -2. If I want to calculate an additional 0, I'm just going to go through the same thing, same process, but I'm going to head over to the second one on the right. Now notice when you are left bound to the second intercept, it's actually below the x-axis for this one. Press enter. Now I want to be right bound. Press enter, and let's see where our second intercept is. It is +2. So graphically, we could see pretty well that our 2 intercepts here were -2 and +2. I hope this video was helpful. Good luck finding those zeros. Bye.